Okay, so welcome everybody to day 3 of Starknet Basecamp. We really appreciate your consistency in joining the sessions, and we hope that you will actually be greatly impacted. And in case you have any questions, let us know. So like we said yesterday, all the recordings and every information will be shared on Notion page. So feel free to check it out whenever you want to make any reference, and just to avoid so many same repetition of same questions in terms of like where can I get the recording, etc. So all the recordings are uploaded on the Notion page, and all the other information also is uploaded on the Notion page. So today we are pleased to have Cindy. She's a great developer, and we love to have her here for this session. I will let Cindy introduce herself, and then you can get started.
Okay. First of all, I hope everyone can hear me. Am I like audible? Yes. Awesome. So, hi everyone. Hi again. My name is Cindy Kamau. I'm from Nairobi, Kenya. I'm a blockchain developer. I mostly love everything and anything infrastructure. So that's where I spend my time on a lot. And also, Rust is my main language. So Cairo is something that comes up, but mostly with Rust. Rust is the language I'm super comfortable in. But otherwise, it's so nice to meet you guys here. I hope we can both enjoy the 2-hour session. I've actually planned it so that I don't want it to be too technical. So I hope you'll enjoy the 2-hour session. Yeah, it's gonna be a super fun session today. Okay, so let me stop repeating myself. Okay, yeah. So yeah, okay, let me start. Let me start. All right, let me just quickly share my screen. Okay. Entire screen, right? Wait. Yeah, you can see my screen, right? All right. So,
yes, you
yeah,
can see it. Maybe you can just enlarge it when you start to maybe get hands-on coding. You can like enlarge it so you can have a clear look, clear view.
it's okay. No worries. So first of all, let me just come here and then put on the slideshow. And then I reduce myself. Yeah. So welcome to session 3 of the H.E.R Kenya Bootcamp. Like I said earlier, my name is Cindy Kamau. Today's session, actually, we will be talking about building on Starknet. So we're going to focus on 3 major concepts today. So let me just wait. Why is it not working? Yeah, okay. Yes. So as I said earlier, my name is Cindy Kamau again. I'm a blockchain developer and I'm also a developer advocate. I actually work as the developer relations lead for Cello, but otherwise primarily I'm a developer. And yeah, here's my Twitter account. Although funny story, today I woke up and like my Twitter account was hacked, so I currently don't have access to it. Somebody else is having access to it. So in the meantime, as we sort everything out there, yeah, I hope I can still be able to like access my account. But otherwise, normally my Twitter account is Cindy Kamau. Okay. So in today's agenda, what I want us to focus much about is, first of all, I will take you guys through Starknet architecture, which is super important. And then I'm going to show you the differences between Cairo and Starknet contracts because with the previous session, even yesterday, with your teacher Sarah, she went into very deep details about Cairo, but there's actually just a bit of significant differences between Cairo as a general purpose programming language, and by general purpose I mean you can actually you can just use Cairo as a normal language outside of Starknet. So just the way you can like code in Rust, you can code in JavaScript, you can code in Cairo outside of incorporating any features of Starknet. And then now Starknet contracts, they're now specifically for Starknet, right? And then we're going to go through the anatomy of a smart contract, what a smart contract looks like, and then we're going to look at some three major concepts in like smart contract, storage, functions, and events. Okay, so the first section is on Starknet architecture. And normally, as usual, the way I love teaching with stories. It helps me and it also helps people to like understand the concepts. So the first storyline which I'm going to give is about a restaurant, right? So just imagine right now you are actually visiting a very fancy restaurant. Actually, Valentine's Day is almost around the corner. So imagine you and your babe, you're just getting into like a restaurant, right? A very fancy one, you've saved money, etc. And then now we're going to go through all the steps that happens, like what exactly happens from the moment you step onto the compound of the restaurant to the time when you leave, right? And we're going to connect all these steps to how the transaction life cycle of a transaction looks like when it goes through the entire architecture of Starknet, right? Okay. Yes, so let's start. So you've already entered into the restaurant compound. The first step you meet is a bouncer. Let's assume you meet a bouncer at the entrance, right? Although bouncers are mostly for like clubs or something, but let's just assume you meet a bouncer at the compound, right? And then obviously when before they even let you in, there's a sort of check that they have to do on you, like, do you have an ID? Do you have this? If maybe the restaurant has some sort of dress code, are you dressed in the dress code like that was given out? All these small checks, which is still at the gate, right? So if you pass the bouncers, the next stage is you're going to enter into the restaurant, and who is going to greet you? The waiter, right? So the waiter will come, hey, hello, welcome to the restaurant, and then they'll sit you down. Let's say you're given like a number. Let's just assume you're given like a receipt number, right? You're like, okay, so table yours is table 45. So you go to table 45 and then you sit down, and then the waiter starts serving you, right? And then afterwards, there's some sort of, let's say, verifications that or let's say requirements that the waiter will come to check on your end, right? Like, let's say if you have enough money, let's assume you have to prepay, right? Also, if it's the restaurant where you have to book beforehand, they're going to go and check and see if you had booked a table just before you came in, and all these other small checks that waiters do, right? So far we've gone through checks twice. So from the bouncers stage to the waiters stage, okay? Then after you've passed the stages, the two stages, they serve you. So you enjoy your food, you eat, you finish, and then afterwards you, let's say, call on the waiter, and then you're like, okay, I want to pay. Well, thank you for the food. So after you pay, the waiter will now go to the cashier, right, or the accountant, and then they'll be like, okay, if the way it happens in Nairobi is normally we pay with mobile money, right? So if I pay with mobile money, they're going to take like the transaction code, they send it to the accountant, and then they check on their end that yes, you have paid and we have received, and then the accountant will come back and they'll give the waiter the receipt, the hotel receipt, and then the waiter gives to you, right? So this receipt is like proof of payment. Okay, I have paid, right? Now, after that, imagine now this, you're just yourself as a guest at the hotel, right? So now from the top level management, they have to wait until let's say all the restaurants or all the guests rather, they've eaten, they've been given services until they leave, and then they update their records, right? So they update everything that has happened during the day, etc. They balance their books, and then they update the hotel records, right? So this is just a quick overview of how the restaurant process looks like, right? So let's now connect what the restaurant process I was talking about to Starknet, right? So the first stage, as you can see, I hope everyone can see my screen well. Yeah, just in case you can, yeah, I think Lavender, you can just hit me up in case there's any questions or somebody can see my screen. but otherwise I think we can continue. So based on the process that I was talking about, right? So we started at the gate and then we went to the bouncer and then we had a check, right? So the bouncers check guests before entry. So how does this connect with Starknet? When you submit a transaction, and by a transaction, I mean, let's say I'm sending Esther some tokens, right? So I'm the sender, she's the receiver. I'm sending, let's say 50 tokens, right? So the first point of contact this transaction goes to is the mempool. It's like a temporary waiting area, like a waiting bay, if I can call it, right? So once these transactions are in the mempool, there are some sort of requirements, like there's some requirements that the mempool goes to check, right? So like example, does your wallet address have balance that is more than the fee? If let's say your transaction had a transaction fee of like, let's say 5 tokens, does your account exceed the 5 tokens? If it does not exceed, your transaction is rejected at the mempool level, similar to how the bouncer will kick you out if you don't have an ID, right? So bouncer, mempool, right? Now, the transactions which are able to pass through the mempool, now they're going to the hotel. So the first point of contact they'll meet is the waiter. When we come to now the component of Starknet, this is equivalent to the sequencer, right? So after the transactions have gone through the mempool, they now reach to the sequencer, right? So the work of this sequencer is just to execute transactions and to build blocks. Once it processes transactions, its work is also to build blocks. And by blocks, I mean the layer 2 blocks, because we have 2 different types of blocks, right? We have the layer 2 blocks for Starknet, and then we have the layer 1 blocks for Ethereum, because Starknet is on top of Ethereum, right? I hope I'm clear so far. So we have our sequencer, so it executes the transactions which have passed the mempool, and then it builds the blocks. It's similar to how the waiter will give you like services, will process everything for you, etc, etc, and then it will process the payment. The waiter will process the payment for you, right? So, oh, sorry. What have I done? Just a sec. Yeah. Yeah. So afterwards, when we now get to the cashier, after you've paid with mobile money, the waiter has taken like the transaction code, they've taken it to the accountant, they've verified on their end that you've really paid the money. So the receipt is printed, right? And normally on our day-to-day life, a receipt is a proof of payment that you've paid. Otherwise, you can't be given a receipt if you haven't paid, right? So when we come to now Starknet, it's the same concept, generally speaking. So after we get to the sequencer, we have the prover, right? So the prover, the work of the prover is all these blocks, all these transactions which are in the blocks, which are from the sequencer, they're sent to the prover, right? So the work of the prover now is to generate a proof that all these transactions have been processed, they've been processed correctly, and everything is okay. There was no like malicious intent, etc. So that is the work of the prover, right? So after the sequencer has executed the transactions, it has built the blocks, they're sent to the prover generates a proof. And normally by generating a proof, the way they work is you'll find like they batch process. So let's say, for example, you can find like, let's say they will generate one proof for like 1,000 or 100,000 transactions. So why is that important? Essentially, it's because it helps the work of Starknet, it helps transactions to be processed very fast from to make sure like it's super fast, right? So with the way they process the transactions and they batch them up, and then they create a single proof, and then that proof is sent to the verifier so that the verifier can be able to verify, and the verifier is Ethereum, right? Like an Ethereum smart contract. It's called the verifier, right? So it will be able to check the proof and see if it's working, right? So this is similar to now the top level management, which we're talking about at the hotel. So after the whole day, the reason why I say the whole day is because remember, by the time Ethereum finalizes transactions and adds all these blocks to a layer 1, which would normally in technical terms we say accepted on L1, right? It takes time. That's why if you remember, the very first day, country cousin was talking about, was creating like a wallet, right? Like a new wallet address, and then he had declared, deployed the smart contract, the contract wallet, and then afterwards you could see like it was saying there was like 7 hours or something, and then somebody asked why is it so long? That's because it takes a bit of time to finalize, or rather how we call it, to settle all these blocks into the main Ethereum state, right? So that to be able to change the state of Ethereum. So it's like a process, right? So it takes time. That's why I likened it to a manager will wait for like almost a whole day to update the records of all the activities and all the money that they've gotten from the guests, right? I hope that's clear. So bouncer, mempool, waiter, sequencer, cashier, approver, and then manager, verifier. Yes. So with that, this is like a transaction life cycle. Although I had also created like a small simulator. So let me just share this, and then we quickly go through that because of the interests of time, right? So with the transaction life cycle, similar to what we were saying, right? So here, these mempools, we call them like gateways, right? So they're the first point of check, our bouncers. So transactions will come here, and then mempools will do validations. And one of the validations, like I talked about when it comes to the mempool, is they want to confirm that your account has amount, like your balance for your account is higher than the transaction fee, or like the gas fee or something, right? So that's one of the checks which happens in the mempool. So once that is done, you can see we have two sort of we have like three arrows, right? So we have transactions which are received and validation which has failed. This is like example with one the first point of check, like the transaction was like rejected, right? So when they all come to the sequencer, and the reason why they all come to the sequencer is we talk about something that we call unknowns, like a number that happens once, right? So the reason why even the transaction that will fail, some of will still come to lose, so that we can be able to add onto the knowns, so that if you try to send the same transaction twice, it will not work. It will ignore. Actually, what happens is if you try to send the same transaction with announs, let me just lightly give it like an ID, right? So the first transaction had an ID of 0, and then it failed, right? And then you try to send the same transaction which has failed, but now it still has the same nonce, ID 0. So because it was already processed, it will be ignored. So the only way it can work is you have to increment the ID, so like you can have ID 1, so that the transaction can be processed. And this, in technical terms, we say it is there to be able to prevent something we call replay attacks and all, right? So to continue to the sequencer, once the sequencer has processed the transactions here, right? And what I wanted to say is, you can see, I hope I'm not wrong, but the reason why it is dotted over here, it's because the transactions which are failing at the mempool, they're not really going to be processed by the sequencer. I'm going to show you the differences between transactions failing in the mempool stage and in the sequencer stage, right? Okay, so we've come to the sequencer. It's received these transactions, right? So after it has received these transactions, if a transaction fails within the sequencer stage, it will still be added to the L2 block, right? If by any chance the transaction passed the mempool stage, but it has failed during the sequencer stage, what will happen is it will still be added to the block. And the reason why they add it to the block is they just want to keep like notice that, okay, let's still add it to the block, and also to try and prevent, I hope I'm not wrong, like DDoS attack, if I'm not wrong, right? So all these transactions, whether they have failed or they have passed, they are always added to the L2 block, right? So this is why you can see here we have two tags. We have the red tag, which is reverted, which means the transaction actually failed, and the the blue text which says accepted on L2, which just means this transaction was successfully be able to be added to the L2 block, right? So bouncer, waiter. And then once we have this, we send it to the prover, right? The accountant. So the prover, the work will be to process all these batch transactions which are being sent from the sequencer. And something, if I may talk about it as a just a by the way, the sequencer, it does not process transactions like in concurrently. So far, I mean, the Starknet, they're still working on like making it to run in parallel. But so far, the sequencer processes one by one. That's why it's called the sequencer, right? It processes in sequence, like just one by one, like that. But when it comes to the prover, like the proof, it's super fast, right? So all these transactions in the block, they come to the prover, and then the prover generates a proof for all these transactions, right? This proof is now sent to Ethereum. So Ethereum, they don't have to rerun all these blocks again to confirm that they were processed correctly. They can just run and verify this proof, which was submitted by Starknet. And then if the proof works out, they do what? They accept all these transactions to what? To the Starknet. Verifier, Starknet core. They so once all these transactions are approved, they get finalized and settled in the mainnet. So actually, the reason why it's because it's an iterative procedure. There's some other steps which I probably have missed talking about, but these are the major steps. So mempool, sequencer, prover, verifier, and then that's it. So to continue, let me just quickly, where did I put it? Yes. Although, in hindsight, could use, okay, so I tried to build like a simple simulator. So it has like my mempool, prover, sequencer, the transactions, and the verifier, so that we can be able to, it's not just theory, you can be able to sort of see how it might work behind the scenes, right? So to do so, let me just yeah. Oh yeah, actually going to the wrong place. Okay, so I don't want us to focus on the code. I just want you guys to see how it looks like. So in the meantime, after the session, I can share like the link for the GitHub. You can go, you can play around with the simulator, you can check it out. You can even try to like convert it into Cairo because I've built it in Rust. Yeah, you can just do whatever. And please don't forget to hit a star. Okay, so let me just run it. So fuck. What? All right. Yes, I'm in the right place now. Okay, so don't mind the warnings. This is something it's still work in progress. So I just hope you can see. Okay, yeah, so this is a Starknet simulator, right? So we can choose an option between the following. We can choose either to view wallet balances, we can choose to like submit a transaction, process the transactions. And by processing the transactions, I mean like they go from the mempool to the sequencer, and then you prove the pending blocks from the prover, and then you verify the proofs on Ethereum, and then you finalize on L1, right? And then you can exit. So the first step is, because I've sort of simulated like a wallet, we can just click on one and we check like which accounts are there first and which balances are there, right? So we have Cindy, Alice, Mike, Mark, and Bob. So once we have this, and remember I have hard coded the tokens, right? Because it's a simulation. So the next step would be, let's just submit a transaction, right? So the first thing would be, we enter like the way you just normally send transactions. So the sender name, I can decide to choose Alice. Oh, yes, 200 tokens. And then now there's something which we didn't talk about, which is there are 3 types of transactions. We've talked about the transaction life cycle in the entire architecture, right? But there are 3 types of the transactions in the 3 major ones in Starknet. That is, we have the invoke, declare, and deploy. So invoke for invoking its the normal transactions, like the normal, if you're sending money, etc, and any other sort of transactions, right? For declare and deploy, they're all involved with the smart contract aspect of it, right? So what I want to do is, if I want to send money to Mark, which type of transaction is that? It's an invoke transaction. If I want to deploy, let's say, a smart contract, which sort of transaction is that? A deploy transaction, right? So let's continue. So let me see who has small money. So let me write on invoke, and then the receiver name is Mark. So yeah, so how much do I want to give him? I just want to give him like 50 tokens, right? So as you can see, first of all is we have like a transaction fee of 5 tokens, which will like be deducted. And then the nonce, this is what I was talking about, like we can call it like a unique ID, right? So each token, once you submit, it has its own nonce, right? And then this is just to say the transaction has been submitted successfully to the mempool. So once we do that, the next step would be, let's try to process this transaction in our mempool, right? So if we put on 3, yeah. So let me take you slowly by slowly. So these are just like when you print what is going on behind the scene. So we have the sequencer, which is processing like one transaction, although it's supposed to be behind like the mempool. So I must have printed the statements wrong. But here we have like the mempool is now validating transaction ID 1. So I gave each transaction like a transaction ID just to show, right? So the mempool has done its the initial requirements, which I was talking about. It's seen Alice's account is greater than the 5 tokens for the transaction fee. So that's a tick. And then it has sent it to the sequencer. The sequencer processes the transaction with still the transaction ID 1. And then you can see that transaction 1 is executed with the sequencer. So I wanted to just see. So Alice's remaining balance is 145. That's because the 5 tokens for transaction fee have already been deducted. And then Mark's new balance is 50 tokens. And then you can see the sequencer outputs block successfully created on L2. So an L2 block has been created. And how does that L2 block look like? So it has only 1 transaction so far, right? And the status is accepted on L2. So if you remember the diagram I was showing, we have like reverted, accepted on L2. So the status is accepted on L2. So the L2 block, which is created, I tried really hard to simulate it with how like a Starknet block looks like. So you have like a block number, which is our first block number. And then for the previous hash, I just put like Genesis hash because I'm sure this is like there's no like previous hash before it, right? So current hash, we have like, this is the current hash of the block. And then the timestamp, although we can't see well, we also need, because I was using like new Unix timestamp. This is just like, so right now is 2039. Let's just say it's at 8:39 p.m. right? So only transactions in the block are 1, and the block status is accepted on L2. So normally when you go check how the blocks for Starknet being produced look like, they will sort of look like this, although there's some other fields I've left out, like state diff, which is something we call state difference, and all these other things. So, and this is the transaction that is in the block 1. So ID 1, nonce, sender Alice, receiver Sam Mark. This is because I put like an option, because based on all this, based on our 3 types of transactions, not everywhere will require like a receiver. So I put like something we call in Rust like an option. Okay, and then status succeeded. So we have now processed our transactions. We haven't created like a proof, right? So we can send this transaction to the prover. Yes. So on option 4, the prover has verified the proof for block 1, and then block 1 has been verified and proof has been generated, and then the proof generated is this. So in Starknet, the proof, if I'm not wrong, is it Poseidon or Poseidon? Poseidon, Poseidon, something along that cocktail, right? So here what I just did, because I couldn't find a way to implement that in Rust, I just used the normal SHA 256, which is used in Bitcoin, right? So the SHA 256 proof, and normally in Ethereum, the Ethereum is the Ketchak one. So this is some of the sort of like elliptic curve and whatever. So anyways, so this is just a way, this is the proof of our what? Of our block, which is in from the prover stage, right? So the last stage obviously is to verify this proof on Ethereum. So we send it, and then it verifies the proof, and then it shows proof for block 1 is valid, and then yay, proof block 1 is now finalized on Ethereum L1, and the block status for here is accepted on L1. Yeah, so this is just a quick Starknet simulator, so that you can be able to also connect from the theory aspects of the architecture to this, right? So yeah, you can, I'll share like the GitHub, you can go, you can play around with it, you can see, you can also try to break it because it's still buggy, I'm sure, but yes. Okay, so with that, let me go to now the slides. Yes. Yes, so far we've talked about the architecture of Starknet. Like I said earlier, you've been able to see the various stages of a transaction lifecycle, from the mempool all the way to being verified in Ethereum. So that's more of it. It's like the foundational aspect of the architecture of Starknet, right? So the next session, which I want us to focus on, is traits and generics in Cairo. So why is this important? It's because when we eventually go to check out the smart contracts, the way they look like, most of the time you'll find yourself implementing something we call traits and generics, and it's super important to at least understand how. Yes, please. Okay. Let me just pause, see if there's any questions.
Yeah, I think there's some questions in the chat. Can you see?
Okay, so where's the chat now? Okay, no, yeah. Oh, yeah. I can't see any questions. Or is it in like the Telegram group or something?
In this chat, can you see the chat or the Q&A?
I can only see one by anonymous attendee. Yes, we can. Like when we started the session.
Oh, okay, no worries. You can just keep going. I will try and get those questions for you.
Okay.
Yeah.
Okay, thank you. Thank you.
Yeah.
All right. So we can go to traits and generics. So before I enter into traits and generics, yes. Hope everyone can still see my screen. So, and with this, we have like another story. So the first story was like a restaurant. Right now, we're now at a construction site, right? So imagine like you work in like a construction site, right? So you have workers. Okay, let's say you are the foreman. or the manager of the construction site, right? So the first thing that you have to do is identify all the tasks which are needed in the construction site. Let's say you're building a house for someone. So what are needed? You will need, let's say, stones, you will need cement, you will need like whatever, you will need shovels and wheelbarrows and all these other things, right? So you identify the tasks. The second thing is how do you ensure that every task is done by the right worker? What do I mean by that? So you will find people who come on a contractual basis, like the normal workers. In Kiswahili, we call them watu wa mkono, right? So the normal workers who come and they have different qualifications, they have different specifications in their work. So there's some of them who are super just casual workers, and some of them are trained professionals in things like wiring and plumbing. So how do you ensure that work which is general, which is like carrying stones, anyone can do it, and work which is for specialized personnel like wiring and electricity, and okay, electricity and wiring is the same thing. Wiring and plumbing and any other sort of specialized duty has the person who's relevant for it, right? So we'll look at this and we'll see how it mirrors what we're talking about in traits and generics in Cairo. Yeah, so just like how we set base in how the entire structure for the restaurant works, we're now at the construction site. So the first step is workers will arrive at the construction site on Monday morning, and then they're divided into two, right? So we have the general tasks like carrying stones. Carrying stones, anyone can carry stones in a wheelbarrow. Carrying cement, anyone can carry, even like layering of the, when you put like the stones, the brick layering, before that guy comes with a thing that hangs and then to ensure the wall is straight and everything. So this is like some general tasks, right? But for specialized tasks, example, electrical and also, like I said, plumbing, you can't just afford to have anyone who just come and decide they want to fix electricity. What if the house catches fire or something because of wires having two shorts and all, right? So the work of the foreman now is to understand and verify. The very first thing you do is you're going to want to check. So you're casual. That means you don't have like any certifications. You're just here for the normal day-to-day labor. And then once that's done, you get your money and then you leave. And then now for these specialized tasks, you want the foreman will want to like confirm, okay, so you have let's say a certification in electrical engineering, or let's say in plumbing, or just some sort of certification, right? So the foreman will verify all this so that it can be able to attack to do what? To divide these tasks among all these people, right? So how does that connect with our concept of traits and generics in Cairo? So first we have the foreman. He's like the manager, right? This is something technical we call trait bounds. They're like requirements which are needed, like they're like restrictions, if I can call them restrictions, to ensure that each worker has the required specifications before tasks are assigned, right? So this is just similar to foreman assigning workers based on their skills. So that's what we call trait bounds, which you're going to see later on. And then we have the general workers who will do anything. So they can do anything. So they don't even need any specifications. You just have to show up and you can do anything that's on ground, on site, right? They can do any flexible tasks. This is now similar to the concept of generics. Generics, it just helps the code to be very flexible. Like you can work with different things. It's just like if I can be able to for guys who are in the front end, I hope it's like a good relation. But for guys in the front end, there's normally those reusable components you like design, right? So we can call them like generics because you can use them in in various parts of your code base, right? So those are just general workers. So for specialized workers, these are now the traits because they have to have specific things. And these restrictions, we call them trait bounds. So the traits are now the specialized workers. Now their skills or their certifications is what we call the trait bounds. It's like they bind them to their specific skill, right? So the specialized workers must show the certifications and all these other things, which are the trait bounds. And then now, when the project manager is ensuring everything is working okay, this is just implementing of these traits to ensure that based on where everyone is kept, every work is done correctly, right? So, okay, with that, before we even go to this, let me see. Yeah, so I've done it twice, right? So it's easier for me to explain this in Rust, first of all, but then on the second aspect of it, where is it? I've created like a Cairo version of it, right? So we're going to look at it twice so that you can also see, in as much as Rust and Starknet, Rust and Cairo, they always look sort of alike, but they have differences in their implementation and syntax, okay? So with that, we can start here. Let me just, okay, that's too big. Okay, let's just sit there, right? So I think we can start. So let's just start with like a main function, right? So let's say we want to like design an algorithm. We can call it an algorithm. We want to like design an algorithm that checks largest number in a list, right? We can call it a list. Just a second. I thought I had disabled this guy. I hate using Copilot sometimes. Yeah, I had disabled. Okay. Yeah, I won't disturb. All right. So let's continue. What was I saying? Yeah, we design an algorithm that will check like the largest number of a list, right? So what do we need in there? We obviously will present like the list. And then we will do what? Once you have the list, you sort of you get the index of, let's say, the first and then string. And then after you get the index, you now sort of iterate. You use it to, you iterate over the items. In the list. Sorry. Yes. So it's just a very simple thing, right? So the reason I want to show you this is before we get to like talk about what I've implemented over here, right? So the first thing would be let just x equals to let's say vec is just a vector, and the difference between a vector and an array, although I don't want to talk too much about it, is but like the difference between a vector and an array is vector is like it's able to grow and shrink in size. If it was an array, let's say let y, and then we say like I32, oh, I32, 5. Hope I've written it correctly. Yeah. Yeah, so this is just an example of an array. So an array, you have to specify, like it's very stagnant. Example, you can see we have to, it's not like very flexible. It's very static, if I can call it static. So you have to specify the number each is inside of the array, and you cannot like it's not easy to like make it grow or shrink in size. So the only time you use an array is when you are very sure of the amount of items you're going to be using in the list. Example, there are only 7 days in a week, right? So there's no day there will be like 8 days. So that's such a scenario where you can use like an array. But normally with other things we use a vector because you're not sure anything can happen, right? So let's just say vector 1, 2, 3, 4, 5. And as you can see here, like normal, the default implementation in Rust is I32. The difference between this and Starknet is the default implementation is the field element, which Sarah also talked about yesterday, the felt 252, right? But anyway, sorry, just a second. Let's continue. So what do we want to do? First of all, we said we have the list, right? So the next thing is we want to get like the index. So to do so, we can say like let largest number equals to like x 0. It's like we're saying you start from like index 0, because with the way the for loop works, you're iterating, right? So you start with step 1, you jump to step 2, you check whether it has fulfilled the requirements, you go like that, like that, like that, like that. Okay. So, so the next step will be for, let me see if I remember. Oh, let me see. So we're going to like iterate over the items in the list, right? So what is the requirement that we're going to say? If this number we have here is greater than the largest number, let's say the largest number skipped to 1, right? And then it went to 2, and then it's comparing with the number which it stored previously. So it will jump to 1, and then it will store 1, it will jump to 2, and then it will store 2, like that. So the moment it jumps to 2, and then it sees like 2 is bigger than the number it had stored previously, which is 1, it changes, and then it can I remember something? It changes, and then it adopts the bigger number. So that's how the algorithm looks like, right? Okay, so if number equals to largest number, what are we going to say? The largest number is equal to the number. Yes. Let me see. Yeah. And that's it. So this is just a simple iteration that we've done, right? And then the next thing we're going to do is we're just going to print. Oh, and by the way, in case I haven't mentioned, if this is the first time you're seeing such a syntax, so when you see me write vec with a question mark, that's something we call macros. You're also going to see it in Cairo, so they're like the same, right? So this macro deals with vectors. This macro is for printing, like printing something and the output to the screen, right? So, so we can say the largest what? The largest number is, and then yep. So we can just run this. And run is just the same with like cargo run. Okay, so this run here, it's behind the scenes, it implements cargo run, right? So as you can see, the largest number is 5, right? So why is this important? You can see here, this spec is like I32, right? So what if we wanted to have like another vector and then iterate on the same thing again, right? So what would be, before we even get to the concept of functions, what do you do essentially? You would do what? You would have to copy and then paste this same thing. And then let's just call it Y. And then we can give it like, let's say we can give it like, can give it, let's say vec u8. You can just give it like a vec u8. U is like an unsigned, sorry, like an unsigned integer, right? So this one by default is vec I32. This one is now like U8. So you'll have to do the same thing. You'll have to like do the same thing, right? So if you have another vector, like another list, you'll have to like do that, you'll have to do that, you'll have to do that. So before we even get to just forget all about this, we're going to talk about it. So before you even get to there, what would be the first thing you would do? Already you will see this, we're recycling a lot of code, right? So that means it's not optimal. So the next step would be, let's make a function. So let's say function largest. And then what will be the parameters? We can say the parameters are X because it's a list, right? And there's something which I'm going to add here. And then let's say we put I32. Let me finish first and then I can talk about it. Return like an I32. And then we start from the beginning the way we were starting. Let mute largest number equals to like what is this called? Yes, X 0. And then but here we have to do something. We'll have to borrow yes. So this is similar to what we were talking about here. So it's just the same. We've just made a function out of it. The only thing is, as you can see here, I'm using something we call an ampersand. This is something we call referencing in Rust. And I will show you the difference between this and in Cairo, which we call snapshots. So reference in Rust, snapshots in Cairo, right? So the only thing we have done here is, remember, let's say normal our X is like a vector, right? And with the rules of Rust, we have like rules of ownership. We have like three major rules in Rust, and one of them is there can only be one owner at a time. So if let X equals to vec, and then let's say let Y equals to X or something. So what it means here is X has given up ownership of the vec. It's now in Y. Right? But what if we wanted to do something? We still want our variable to be X, but what if we wanted to do something like some sort of things with the data which is being stored in the variable, but we don't want like X to give up ownership of it's the data inside of it, right? So what we're going to do is we say something we reference it. It's like you're borrowing it. So it's like you're saying, okay, just give me some bit of sugar, I will return back. Instead of taking the whole sugar, you just take a bit and then you return it back to the owner. So it's the same. So what you're seeing here is something we now call a slice. Yes. But anyway, I don't want to be too jargony, but just to what I've said is the reason why we haven't said like X32 is because remember we're doing some of the things here. We are iterating, and with the way, no, let me not go deeper. But if you want to go deep into Rust, when you go check like the way for loops work, they implement something we call the into iterator treat, right? So it's something else. But let's just continue. Yeah, so you have to borrow it so that if you're iterating over it, it doesn't like the ownership doesn't move around, if I can say so. Like I said, one of the rules of Rust is there can only be one owner at a time, right? So once we have this, so this is like what we were talking about, right? So you have to like borrow it so that you can like do whatever you want, and then the ownership will not be remaining to like this number, for example, right? So with that, okay, let's change here. So we can say maybe net result equals to, and then we call our, and then remember we were like borrowing it. Let's see. Okay, and then we do what? We print. So as you see, the way you the parameters you include here, they have to be very they have to be like exactly with what you're saying here. So if you're saying you're borrowing a list, and just because I've written here X doesn't mean that it's only going to work with X. This is just a placeholder, right? It's just a parameter, just to say it's like if I wanted to say like maybe Y or Z, it wouldn't really matter. So the way we borrowed our vector here so that we can we can like skip on it and get the largest number and then return it to the owner. It's the same thing you're going to do here. And then we print a statement saying, so instead of largest number, we say result. Yeah. So let me just quickly run it. We see. Yeah, it's still the same thing. You can see, right? But now the issue is, why are we still having an issue? Remember, this function largest here, it works when, because it's supposed to, it only works with parameters which are I32 in nature, right? So what if I have another vector and it's of another, let's say U8, like we had done here previously, right? So what will happen next? Because if I try to use the largest function on this vector here on Y, it's not going to work, because you see it's supposed to return what? It's supposed to return an I32. Here we're working with an U8. And the way we know is Rust is a very strongly typed language. So it is very strict on these rules, especially with type enforcements, right? So it's not going to work. So what is the next step which you would think to do? You would now have to start like writing, let's say this becomes like largest I32, and then you now have another one, largest, like you wait, and then you have another one, and then you continue, and then you continue. And remember, these are just integers. You haven't even, and if you wanted to like work with strings, you wanted to work with this, can you see where I'm headed to, right? So this is not really working, okay, as you can see so far, because you will have a very big code base, and the knowledge and the logic is just redundant. So what can we do about this? This is where now the concept of traits and generics, they come in, right? And I'm going to try and connect with the analogy which you're talking about. So here we were just before we even implemented like the traits generics. So I can just do key. You. Why are you not? Yep, I think everything is. I think so. Okay, so we can. Where was I? Yeah. So based on what I was trying to show, I want to take you guys through step by step what I talk about when it comes to traits and generics, right? So the first step we need to consider is we have to consider all the types which we will need. And by types, I mean we're going to do integers, we're going to have floats. Floats is like the decimals, right? We're going to have strings, we're going to have whatever custom data type that you're going to have. You have to ensure that if you want your piece of code logic to be reusable across your code base, it has to handle as many, it has to be very flexible. That's what we were talking about, flexibility. It has to be very flexible to do what? To work here, to work there. When we come back to the analogy of the construction site, this is similar to saying these were the normal casual workers who were flexible and they can work here, they can work there. They're not constrained to just one field because they can work anywhere. They're just casual workers, right? So that's now what we call generics. So with generics, it just ensures your code has to be very flexible and it has to work across all your different implementations in the code base, right? Yeah. But now it's not just enough to only consider the generics. We also have to consider what are the sort of requirements or like the sort of restrictions you're going to input. Because now, like I said, remember, Rust has a very strict rules, right? And let me give you an example. If you see the way here, number is like largest to the number, like the binary, this is like a binary operator, right? If you can see this is just syntactical, what we call syntactical sugar. The same with like a for loop, right? So behind the scenes, there's some implementations which are happening, but to make it easier for us developers to write, they just put it as simply like this. So the reason why it's working, it's because it's working with types it knows. Example, I32. But now we're sort of sending the compiler to the wild end, to the wild west, rather, because we want it to handle any and every type. So it will now wonder, okay, what if I don't know how to implement like the greater than sign on a type, because it's like a custom type, what am I going to do? So that's where traits and trait bounds come in. So they sort of guide, in as much as you're making your code to be very flexible, they sort of guide to ensure there's some set requirements. If you want your code to work that way, you sort of write the requirements so that you can be able to see like the behavior of your code, the way it looks like, right? First of all, let me just take a quick breather, just ensure everyone is at the same page. I keep on losing this. Yeah, let me just put myself there. I hope, okay, let me see. All right. So I'm not seeing any questions. So I don't know if maybe I'm also going too fast or I've started to talk about too much technical jargon. It would really help me to like know. Yeah. In case you have any questions, please raise your hand, right?
Yeah, I think everybody is understanding because the whole concept of storytelling is really exciting and it's really good. So I hope that in case anyone has a question, please don't hesitate. Yeah, also feel free if you are enjoying the session, take a quick screenshot, post about it. We love to see it. But yeah.
Okay, so that's just a quick breather. Let me just take some water to drink. All right, let's continue. So where were we? Yes. Yeah, so like I was saying, right? So
Cindy,
it just
sorry.
helps to,
Sorry
yes.
for interrupting you. Sorry for interrupting you. I just saw in the chat someone asking you to zoom in the VS Code a little bit.
Oh, okay.
Yeah,
It's already zoomed in. It's already actually at max. Because
oh
if I
yeah,
try to zoom in again, it's yeah.
okay,
Because let me see. Oh, okay.
nice. Oh,
Think
yeah,
isn't this too big?
I think it's,
Okay, there.
yeah,
Is that okay?
yeah, I think it's fine. It's visible enough.
All right, let me also just do that. So what was I even talking about? Yeah, I was just explaining the whole concept of, let me just remove myself, traits and bounds, right? yeah, so example, let me show you what is happening over here. Actually, let me just do what? Actually, we could just rewrite this. There's no big deal. Yeah, so we now have our function largest, right? Let's just put it like that. But let me just come down and show you guys. But instead of picking like an I32, we wanted to do what? We wanted to pick, ooh, we wanted to pick like, we wanted to be a slice of like any type, right? So T is just a placeholder. We just call it type. It's very common when you're talking about generics, because if a fellow developer sees T, they can be able to understand. But otherwise, if you want to, you can call it, I don't know, element, you can call it X, you can call it Y. It's just that T is favorite because it's universally recognizable. So yeah, so previously, if you could see, actually, let me just, yeah, so it's easier. So previously, like if you could see, our X was what? Our X was a slice of I32, and it was supposed to return an I32. Here, what we're just saying is it can come in any type, whether it is a float, whether it is an uint, whether it is an assigned integer, whatever. It can come in any form, right? But this cannot work like this. You know, like even the compiler is complaining, cannot find type T in this scope. So you sort of have to like give more info. What is this T about? Because the compiler does not know what a T is essentially. So that's why you'll come and you'll write T here, right? So it's just giving it like okay, more info that what, like we're just giving it more info, right? And then something else, what I was now talking about, the trait bounds, right? You sort of have to give I think it would be nice if we continue. Yeah, we haven't. I think it would be nice if we continue, then you can see the error and then we can explain why. So we still do the same thing, net, mute, just number. Ooh. Like that. Mhm. Then we return highest number. Yes. So this is what I'm talking about. So already, if you can see, let's go check the full compiler diagnostic. Already, if you can see, binary operation greater than cannot be applied to type T. What does that mean? Like the compiler does not know what data type will be here when you implement this largest function, right? It doesn't know. So with that, you have to like sort of give it some sort of restriction so that it can be able to apply them. If we want to like put the greater than, you have to sort of specify what are you going to use so that the compiler can be able to apply the binary operation greater than, right? So what I mean by that is there's some traits which we call standard. Standard is just the standard library, and then const, and then it's called partial order. Have I written it correctly? Yes. So T, standard comp, partial odd. So with partial odd, it's normally used when you're like comparing things, because with the binary, like the binary operation greater than, we're like comparing one number with a number, right? And we want to see which one is greater than the other. So normally with like things like if we can go back with things like integers, this is built in. That's why you don't have to import this trait over here, the partial odd. You don't have to import it, because when you're working with like integers, it's built in, right? But now, since we're working with custom any sort of data type, you have to specify, right? So we have that. Okay, consider borrowing here. So this is now another error. Cannot move out of type T, a non-copy slice. You cannot move here. Move occurs because X has type T, which does not implement the what? The copy trait. So this is very important when you check this error here. So it's saying this when we were trying to like say the largest number is like index 0 of X, there's something we call like the borrow checker in Rust. It's complaining because it's like it cannot move out of here. Move occurs because X has type T, which does not implement the what? The copy trait. So normally when you see this is because when we were working with like the integer, the I32, that's because behind the scenes, the copy trait, for it to be able to copy, like, remember when we were like borrowing and all these other shenanigans, to be able to copy it, it was already like implemented. That's why we didn't have a big issue. But now, because we're working with type T, which means we can even work with strings. And the way strings are copied is so very different with the way integers work, because we now have two types of traits. We have the copy trait and we have the clone trait. So anyway, let me avoid becoming too jargonistic, but that's what I was trying to say, right? So essentially, what we have to do also is we have to implement like the copy trait. So it's like we're trying to, so these are now the trait bounds which are talking about, like the certifications which you're talking about. So we're like, so once the compiler has this, like it can be able to do what? It can be able to what's the terminology? I've forgotten. Yeah, comparison, right? It can be able to compare with partial odd, and with copy, it can be able to sort of copy whatever it wants to copy, right? Normally, copy we work with integers like I32 and whatever. So once we have this, we can now come here. It's now working okay. As you can see, you can work on this with everything, which we're going to check. So the first thing, which was like the normal vector, and then we have like the largest, and normally as usual, you do what? You borrow the no list variable and then you print. And then also with characters are like this. You can do the same thing, and then we can use the largest function to get like the largest character, right? So the reason why I haven't included strings here, it's because I said that's now a totally different point of view, and I didn't want to go too deep into that, because instead of copy, we would have had to implement clone. And that's now another. So in case we were to implement clone, we would have started to clone over here and so many other shenanigans, right? Forgot. Okay, we'll debug that later, but yeah, so yeah, let me just not mess it up. So yeah, we think we can run it and then you can see. So if you can be able to see here, like the largest number is 5 based on our first list, and the largest character is what? Is E. So you can see it's able to dynamically work with any sort of what? Any sort of data type which you give it, right? So this is now what we talk about when it comes to traits and generics. But remember something else which you're going to, even when you like continue with your development journey, especially in Starknet, what's happening is on our end, we might have reduced the code right? Because you can see it's just smaller. But now behind the scenes, it's sort of creating copies. So like, first of all, if we want to like find the largest number of this, it will have to do that first and sort of like create copies, really. And then now for the character, it will have to do the same thing. So on our end, the code is small, but when it comes to like behind the scenes, the code is still bigger. Just like how you would have implemented this when you would have like regurgitated the redundant code. So the code becomes a bit redundant. So it's something we say when you're like building smart contracts in Cairo. In as much as you will be using like the concept of traits and generics, you have to also factor in the fact that your smart contract might be increasing in size behind the scenes, and that means more computational power, and that means you're going to have to pay more gas fees and so many other things. So this is just small design implementations which you have to consider, especially when you're like writing smart contracts, right? Yeah. So okay, let me first pause, see if there's any questions. I'm always keeping on forgetting where the screen is. Yeah. So do we have any questions? Guys, you're so quiet. I'm so worried because I don't know if anyone is understanding, or I'm becoming too, let me see. Perfect right now. Okay. 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 So just in case you haven't understood anything, I just want everyone to come out having understood something from the session. You don't it doesn't have to be everything, just something. Yeah, that would be like a win-win for everyone, right? But in case you haven't understood everything I've said so far, you can also talk to like the Telegram group in case you have any questions, in case you have any follow-ups from that, and then we'll be able to help you from there, right? Okay. So just a quick break. We've done with like traits and generics. So to just give you guys an overview of what we've learned so far, first of all, we started with the Starknet architecture. We saw like through the restaurant model how the transaction life cycle of a transaction works in Starknet, right? So you start with the mempool, you go to the sequencer, you go to the prover, you go to the verifier, and then it's included on Ethereum, which is L1, right? Once we went through that, the next thing we went through is the concept of traits and generics, where I was talking about the construction side, where I said generics will be sort of like the general workers, the casual workers who can do anything. They're very flexible. They can carry stones, they can do this, they can carry cement. That's the whole concept of generics. Now with traits and trait bounds, it now applies to those specific restrictions, just like how we said in the analogy, we need specialized people to do specialized tasks, right? So you need an electrician to come and do wiring and a plumber to come do plumbing. And the trait bounds will sort of be like, they have to show proof that this is they have the skill set needed to do this, right? So it's just the restriction and the requirements. Just like how when we've done in the code I've shown you, it's like you're giving a condition. You're like, okay, so if you meet this type and we want to do this, we want to iterate and we want to find the number that is greater than the other one, you do what? You implement that partial odd trait, and you also do what? You also implement the copy trait. And if we wanted to, like, that is a very simple implementation. If we wanted to also consider very complex data structures like strings, we could have implemented instead clone trait instead of copy trait, right? Yes. So that's just a quick overview. Okay. So just a small breather. Ensure you've like understood everything. I also don't want to take it too fast. There's no point in rushing and people haven't understood, right? Okay. So essentially, this is how you implement it in Rust. But what about Cairo? Because Cairo is like the main star of the show today, right? So, okay, no, that's not it. Yeah. So what I'll do is sort of, Yes. Ooh, so this one is not big. Let's see if we can like. All right. At the back. Yeah. Oh, that will be not easy to follow. Ooh. Okay, let's see. And then we come here and we do the same thing. Oh, sorry. Yeah, I hope guys can see. I hope guys can see my two screens. In case, let me just pause for a bit. In case you cannot see the code properly, because I have two VS Code instances here, the red one for Rust and I have the blue one for Cairo, so that I can show you guys just the difference, right, in how it would look like in both implementations. So just a sec. Sorry. So this is how we implemented it in when we were looking at the largest function, right? So here the only thing I've done is I've implemented like now the opposite, the smaller element, the opposite. We're finding like the small element in a list, right? So first of all, before we even get here, let's get to the function main, because normally that's where someone starts and then you work from behind, right? So here we did for ours it's a vector, right? For the Cairo implementation, it's actually an array. And you can see the difference between Rust and Cairo. Like you see for this array implementation, it's something we call a macro, right? So here, this is now an array. If we wanted to look like an array, we would have said like let y, like how I had yes. So these are the two differences. Like you can see, they have some sort of similarity. It's just that there's a difference in the syntax. Okay. So this is how we create like an array in Rust. This is how an array looks like in Cairo. Example, this is like what we call the type, and like when you like writing your type, right? So you can see here, it follows this format we call like something like that, like the type and then the number. This is how arrays mostly look like. So if you find yourself in the journey of learning Rust, remember when you are like writing the type annotation for an array, you first have to start with the type and then you have to specify the number, right? Okay. But when we come to Cairo, as you can see, you're sort of writing it just a bit different. So you just have to like type the array and then you have to specify which sort of array type are you going to work with. Like here we're working with an U8, right? That's one difference. The second difference is, let's check about this. Look at the largest number equals to largest, and then we reference the no list, right? So when we now come to Cairo, it's still the same thing actually, because it was like let resource equals to small element. What is the difference is here I cannot put an ampersand the way we normally put in Rust. Here instead of it's the @ right? And in Cairo, we don't call it like referencing, we call it snapshots, like taking a snapshot. It's like I'm just borrowing. That's why I'm taking a a snapshot, like let's say like a screenshot. If you take a screenshot of something, you can't be able to like edit it or something, right? So we can just use that analogy. So if we're talking about snapshots, I'm just borrowing it and there's nothing, I'm not going to like modify anything from there, right? So this is another key difference. So in Rust, we use the ampersand and we call it referencing. In Cairo, we use the @ and we call it snapshot, right? Yeah. And for assert, it's just similar to like when you even like start trying to write tests, you're going to use like the assert micro and the assert equal micro a lot. Yeah, so we're just asserting, we're just confirming, if I can use the word, we're just confirming that once this small element, the smallest element function is applied to this array, the smallest element will be 1, right? So it's just asserting. So with that out of the way, let's get back to our star of the show when it comes to traits and generics, right? So function is still the same, and the way you write even your function names is still similar. So what you can see here, it's a bit different. Like they're almost similar, but they're just different, right? So first of all, we have our T here to represent the type. And while here we put a colon, here we put like a comma. So I can't put like it that way. I have to put like a comma. So this is just some of the subtle differences between these two languages, but they sort of relate with each other, they're cousins. So with that, the first thing we implemented was the partial odd. And in Rust, it's available where? In the standard library. That's why we had to write out the entire path, right? In here, if you can see, we have something we call impl, and it is just implement. Example, it's like what if we just like implement something or something like that. If, yeah, it's just an implementation, right? So we implement it, and then the implementation, we give it like a specific name. We call it like T partial odd to show like I've noticed with Cairo, they're very specific with the way they name things, right? So you implement T partial odd, and what are you implementing? We implement the same thing we did here with standard comp partial odd T. And like I said, partial order is when you're comparing two things, okay? Now, the same thing which is here is implement copy for copy, right? And then the only difference is now we have something we call implement drop. So as you can see, they're just very related, but they're just subtle differences, right? But if this is too wordy for you, there's a way you can write it. Like you use like a plus, right? So instead of writing like impl T copy T, like example, we can just, and then we use a plus like that. Instead of T drop, etc. Oh, don't know why that is. Yeah, but it's just the same. It's almost the same thing, right? With just subtle differences. So once you get used to the syntax and you understand the foundational, the whole aspect of me talking about this is I wanted you guys to understand the foundational of why we use traits and generics. So don't worry too much about the syntax for now. This is something you just learn alone slowly in your own pace. So there's no like worry, provided you understand the foundational and the principles. The principles is what matters a lot. It's not even the syntax in anything. But anyways, otherwise something here which is worth mentioning is we have this in Cairo. I think it's called desnapshotting, because in Rust we call it dereferencing, but in Cairo it's called desnapshotting or something. Yeah, but let's not go too much into the details. I just wanted you guys to see the difference between if you want to implement traits and generics between normal Rust and Cairo. So when we get back to here, Okay, stop. I wanted to get this. Oh, for some reason I can't be able to. And I've already mixed them. So let's just do this. So let's just run this and then you can see how the Cairo, okay. So clear. And then with Rust, it's Kagoran, right? With Cairo, it's tab Cairo run. Yeah, so because we're asserting, we haven't really said that it needs to be an output. It's just like we're confirming that it's working. Okay, yeah. Otherwise, okay. Oh, yeah. Yeah, so this is just another use case. So I'll share all these code snippets as gist. So this is just another, but it's in Rust though. I had just tried showing like the implementation and everything. So like we were just trying to like code out the construction site and you can see how traits and generics work, right? So with that, let me also quickly take you guys through. Like I said, I don't want to focus too much on the technicalities. I just want you to come out with, even if it's a principle or two, right? So with that, what are we saying? Like I said in the beginning of the session, with Cairo, it's a general purpose program, right? So you can actually code it the way we just code normally. You can actually code with Cairo, and it doesn't have to be related to Starknet at all. It's just standalone. Now with smart contracts, there's a tiny differences here and there. With smart contracts, they don't have example the main function. Like when you saw previously, when you having like especially programs which are like compiling, you need like a main function. That's like the entry point so that the compiler can know what is it running. So it always needs to have a main function. But with contracts, you don't really need a main function, right? Oh, okay, yes. Yeah. So overall, the goal of Cairo is to produce like general purpose provable programs. By that, what I mean is once I write a program in Cairo, and then I sort of run it, it in the behind the scenes, it creates a proof of the program. So someone can go and test the proof of that program and verify if it's working or not, right? So that's what we mean by provable programs. That's why even Starknet designed Cairo, because they built Cairo to be that way, because they are very bullish on zero knowledge proofs and everything, right? So they designed Cairo to create like proof. So when you run it and behind the scenes with the virtual machine and everything else, it sort of creates a proof over there, even in the stage of like the prover and all, right? So, but with smart contracts, if you remember, when I was showing like the picture of where's that picture? Yes, this. You can see the prover has something we call Starknet OS. Normally it's called SNOS or something. So this Starknet OS, its work is to process all these transactions and to generate a proof. So the whole point of smart contracts is the programs which you write when you write like a smart contract, they are designed to run within the OS, right? So it's not really the virtual machine, it's within the OS, right? So like I said, you can create provable programs outside of Starknet, but the smart contracts for Starknet are exclusively for the Starknet network. And the Cairo program are run by the virtual machine. That's why it's sort of general purpose. But with Starknet contracts, and this is very important, they're run by the sequencer. So when you like deploy a smart contract and everything, it's not really run by the virtual machine. That's the work of general purpose Cairo programs. It's now run by the sequencer. That's why we're saying it's designed to run within the Starknet OS. So once it's run by the sequencer and it's sent to the prover, which has the Starknet operating system, which generates the proof and everything. Yeah, so that's why they're not really different, but there's several extra aspects into smart contracts, which are not into Cairo. Okay, so with that, our last story of the day. So we started with the restaurant. Again, we had the construction site. So the last story for today is the smart factory. Just a second. I think we can all have like a breather. Okay, sorry. So what is the smart factory? So now, when it comes to like this anatomy of a smart contract, I just want you guys to like visualize a very high-techy automated factory. Okay, so the work of this factory is to build and ship products. Build and ship products, whether it's Tupperware, whether it's, I don't know, clothes, anything. So its work is to just build the products and to ship them. Let's say cups. We can work with cups, right? So each part of this factory of ours, they represent key components of a smart contract in Cairo. Okay, so the end goal of this section, for on my end, I would feel nice if at least you just remember the key components of a smart contract in Cairo. Remember, we might not be able to understand or remember all the syntax in one day, but if you remember the principles, it will be easier to iterate and reinforce, right? So yeah, so I think with that, we can now go to the key components of the smart contract, talking about a factory. Yes. So what happens in our smart factory? First of all, the factory warehouse, it stores two things. It stores raw materials and it stores finished products. Those are like two types of things our warehouse in the factory stores, right? Then the machines, they process things like any materials, any product, and anything. Their work is to like process everything and come out with the final product, right? So obviously, as in any other factory, there are some access rules or rather access restrictions. So there's a point a visitor cannot be able to access some parts of the factory that an employee or a manager. Oh, okay, let's start with the guest. There's a certain level on the smart factory, the guest will not be able to lend and enter to the restricted, right? So it's only the employee who can be able to access that part of the factory. And also with the employee, there's also certain aspects of the factory that it's only the manager who can be able to access. So it's like a restricted systems. We have some access rules. Yes, so we have areas which are open, anyone can come and see, but we have restricted areas also. Then something else. Let's say we have like an announcement system. Let's say we have like an AP. Are they called AP? I hope they're called AP, just some announcement system, right? So in case something happens, let's say we have new orders which have come in, the announcer shouts at the system, and he's like, okay, we have new orders coming in, we have new shipments coming in, we have new this, we have new that. So the whole aspect of the announcement system, it's just to give updates when important things happen, right? So remember the four concepts here, right? So we have the storage, like we have storing raw materials and finishing products. We have the whole point of processing. So we like processing materials and everything else. And we have rules. We have areas which may be public, areas which may be private, right? And we have the announcement system. So in case of any event, you're able to know what's happening. So because it will be announcing in case of any major important event, right? So just like how I've started mentioning slowly by slowly some of the topics, like some of the parts of a smart contract. Like in a smart contract, what's an important part? Storage. Ooh, I wasn't done. The first aspect of a smart contract is storage. So what are you going to store? You're going to store it where? Because storage is a very important thing. Because if you're like going to store any sort of data in blockchain, you have to sort of specify you'll be storing in blockchain, right? So we have storage as one thing. The one other thing is we have this process of like processing. This is where now like we're starting to work on something, right? So the whole process of processing materials, assembling products. Let's just say this is where you're now starting to like flesh out the logic of your contract, right? With rules, this is mostly with process materials. We can say it's like we talk about functions, right? And methods. So when we come to access rules, this means there are some functions which are private. That means they're very restricted. They're not supposed to be seen. They're only supposed to like work within the smart contract in itself, because we have two sort of functions. We have private functions, which are just restricted within the smart contract, and then we have public ones and also external ones, right? We have also public public functions, which do what? They are allowed to interact with the world. Because remember, the smart contract in itself, it's like a box. It does not know what is happening within the world. So you sort of have to connect it so you can be able to get updates real time and work on them, right? So that's why, like I said, we have access rules, we have private functions, and we have public functions, okay? Now, with the factory announcement system, this is what I was talking about when we talk about events. So when I talk about events, just remember the announcement system. In case something major is happening, you see someone shouting, okay, the new batch which we were producing is now over, right? So that's like an event. So it's triggered when something is happening. So it's sort of a log, you know, it's sort of a log to just like announce, hey, something and something and something has happened, right? So we have storage, we have the methods, we have private, public methods, and we have events. So with that, those are some of the four major components when you have to think of when you're designing your smart contract, right? Storage, implementation, access rules, which methods do you want them to be private, which methods do you want them to be public, and are you going to log any events? Okay, so yeah, so it's still the same thing. Like engineers, when the factory is being built, engineers will like draft a blueprint for the factory. So just the last thing, and then we can finish. Where did I put the storage? Yes. So I'll be like let me just, yeah. So we can be checking them out intermittently, right? So when we talk about, before we even open our factory, we have like a blueprint for it, right? They have to design, the architects, wherever. This is the same thing as what we talk about here. So when you, okay, let me just, yes, okay. Yeah, so every entry, the first entry point of a smart contract is you have to write this attribute here, Starknet interface. It's like, and what does this Starknet interface do? Here, this is the blueprint. It's like you're showing a preview, if I call it a preview, of the functionalities you have put in your smart contract. Like you see, we have implemented what? We have implemented, which is where it has the impl. We have implemented set, just to like, let's say, append some storage, and we have implemented get, which is to read. If we want to like read the data we have stored, right? So that's why it's here. So this T contract state, if you remember when we were talking about how Cairo has its very specific way of naming things, so it's like a type, right? So it's like you're representing like the state of the contract, okay? And this is the trait, and this is the trait I simple storage. It just means your module simple storage, right? That's why it has this I over here, and then your contract state has its T over here, right? So when we talk about blueprints, immediately you see this, the first thing you should remember is our factory, the architect, the designing blueprints, it's going to show the entire factory how it looks like, right? So it's just a preview of the functionalities you have included in your smart contract. So all the methods, if you write many methods over here, you are supposed to like also put them in the trade, right? So that's one. Now, construction workers build the factory based on the blueprint. So based on our blueprint over here, where do we implement our methods? Here we have this ABI attribute. Let me just call it an attribute. We have this ABI attribute over here, right? And something else is the way you write this hashtag and then the square brackets and etc. It's also similar to how you do it in Rust, right? So here, this is like now the construction workers, based on the blueprint which we put here, and by the blueprint we said we just want to store data and we want to get data, right? Based on the blueprint, you now implement the methods that you showed here. That's why we have it. So once you see this ABI attribute, you know that you're going to be implementing the methods based on the blueprint, right? So storage, we talked about storage. Every factory will have like will need like designated sorry, will need like designated storage. We'll need like, oh Jesus, we'll need like designated storage areas for, we talked about raw materials and products, right? So that is implemented by this attribute called storage. So here, when you write this storage, this is like you want to store permanently, permanently. Oh yeah, permanently data. It's similar to how if you have like a background in Solidity, there was something we were calling state storage, right? So it's almost similar if I'm not wrong. It's like you're storing something permanently on blockchain. Okay. So what have we seen so far? So based on our factory warehouse, the architects design the what? Design the blueprint. Right? Ooh. Then here, when we came here, the construction workers did what? They built the factory based on the blueprint. Ooh, based on the blueprint, right? And here, when we talk about storage, so oh wait, okay. When we talk about storage, wait. Request text document code action field. Okay, we'll fix that later. So when it comes to storage, we can assume like the factory house is like done, and it has like a storage compartment for our data, right? So yeah, this is some of the and here we are right now. So these are some of the principles behind the smart contract. Like we have the blueprint, you need storage, and you need to implement your whatever you've put in your blueprint. So you might, as of course we said, we might not remember this. And also we haven't talked about so many things because example, there's this storage pointer read access, storage pointer write access, and so many other things. But at least for today, you can remember that there's some certain principles which are important when it comes to smart contracts. We have the blueprint, we have the storage, we have the implementation, and we have the events, of which our simple smart contract doesn't have an event. So let me quickly where's my, yes. Let me see if I've left something. So you remember, like we have these functions here, right? And I almost forgot to talk about it. So let's remove this, writing one value and reading one value. If you can see something here, when you check our function set, it has this reference over here, like it is referring to itself, right? T-contract state. And you can see we haven't taken a snapshot of it because it's writing, like it's going to write something, it's going to change something we call the state. It's going to change the state, right? But now when we are only reading data, it's like, remember we take a snapshot, or we can call it screenshot. It's like we're taking a screenshot of the current state, the way it is. We're not modifying anything. We're just taking the current screenshot and be able to read it. So this is what I was talking. So we have writing and reading. So there's so many sort of like implementations, right? So we have like the writing to the state, which you have to implement this ref, and you're not going to borrow because you're directly modifying the state. And when you're reading it, you're going to use an at snapshot, which means you're just going to be reading to the state. But still, to still reinforce what you're talking about, always remember the principles of the smart contract. You have like the blueprint here in the beginning. Once you do the blueprint, the next thing you have to implement is storage, because you have to figure out what data are you going to be storing in your blockchain, right? And then once you have the storage, the next session is like the implementation. Based on your blueprint, you have to implement. So those are like, I could say, the three main things to consider. And then you have to consider other things like we have the events, which I haven't shown you yet. So it's supposed to be like events that normally they're normally written with something like this, but let me just quickly show you guys from like the Cairo book. I think I forgot to like add the slide on. Yeah. So in the interest of time, I do believe that is what I would really want you to like understand. So remember the blueprints, remember the principles of traits and generics, and also remember what we talked about when we were talking about the transaction cycle of a of a transaction. Okay. Yes. So yes, this is what I was talking. I've actually forgot to add some events. So when we talk about events, remember this is now the fourth important aspect. When you see events, remember like the PA, yes, the PA system, giving announcements. Hey, this is happening. Hey, this has happened now. Hey, this will happen tomorrow. So that's what we mean by events. So they're normally written with the event attribute. Okay. So this is just to show once this smart contract is running, when it starts running, in case this event here is triggered, it's sort of logged to the system, right? In case a book is added to this registry, it is sort of logged on this day, It actually works similar to how smart contracts and Solidity work, right? So when you work with like events in Solidity, and then after you run the smart contract, there's always that logging system. You can see if an event is like triggered, so it shows you the timestamp and whatever, and all the details. Yeah, so it's just an announcement system. So based on that, I could say is okay, so where's my slides? Yeah, so based on that, I could say I would want to yeah, so with that, we haven't really gone through like this is just like now extra information, like how storage looks like. When we talk about storage, you can imagine like a shelf. Let's imagine like a big shelf in our storage, in our warehouse, and it has some slots. And in each slot, it has a specific space to hold a specific item, right? So that's how I always see when I visualize the way storage will look like, because I like slots and it's a map and everything. So imagine now in our warehouse, we have this huge shelves, and they have a certain number of like 2 to the power of 251 shelves, and they hold certain ingredients, and these ingredients they're held in 252. Okay, yeah, but this is like I said, when you see contract functions, always remember this is now when we are implementing whatever we were talking about in the blueprint, right? And like I said, we have two. First of all, we have functions which write to the state, and they use ref like this, and functions which only read. You have to borrow, you have to create like a snapshot, right? Yeah, so and the same thing, public and private functions. This goes back to our like I said, we have access rules. So there's some functions which only work within the confinement of the smart contract, right? But those are now like private functions. But when we now come to functions which have to interact with the world, they're now like public functions. So these are just variations, but for the last time, the principles, which I would say, which at least you can reinforce them, is always remember the first entry point of the smart contract is the blueprint, which shows all the functionalities which you want to put in your smart contract. After that, the next step you talk about is storage. You have to figure out what are you going to store, which sort of data are you going to store in the blockchain. And also remember, storing data in the blockchain is very expensive. So you also have to like figure out design implications. You're like, if I store this much data in blockchain, will it be costly to maintain it over there, right? Those are some of the design principles. The next thing we talked about is what was it? Yes, the construction workers who build the factory based on the blueprint. These are now implementing your functions based on how you put them in the trait, in the interface over there, right? And then finally, you have like and based on the implementation, based on the constructions, you have different sort of functionalities. You have private functions, public functions, write only functions, read only functions, where you create a screenshot. Let's call it a screenshot, but technically it's a snapshot, right? You create a snapshot of the current state, and you with write, you don't take any snapshot because you're directly modifying to the state, right? And yeah, in case you want to if you want to log down if certain conditions are triggered, we have the events. So you always remember you will need a PA system, so that we can always remember that we need like an event, so that if once it's triggered, we can be able to lock down and be able to monitor what is happening. So it's always good for logging. Okay. Yeah. Yeah, with that, let's come to the end, because we also don't want to like continue reading for 3 for 3 hours. Yeah. I do hope, let me see, I do hope yes, I do hope honestly you've understood something out of this 2-hour session. I hope you can be able to like what's happening? Yeah. I hope you can be able to, I hope you've come out with something, right? So when you go to the restaurant, you remember the whole mempool structure from the bouncer. When you're going to the club this Friday, don't go to the club and forget the transaction life cycle of Starknet, right? When you go to Mjengo, okay, Mjengo in English is when you go to work in a construction site, just remember, when you're given the work to carry stones, carry cement, that's generics. But if you needed specific skills, it doesn't even just have to apply with like construction site. In anywhere you go and they tell you, we just need you to do this and this. Always remember, we have what? We have generics. But if they need something specific from you, if they need you to show like your resume, your certifications and everything else, you remember that's what? That's traits and trait bounds, right? And then finally, when it comes to the principles of the smart contracts, always remember the first point is you have the blueprint. Your architect, sorry, designs the blueprint of your house. That's the interface at the very beginning, right? You have your blueprint. The next step is, what are you going to store in your house? That's also very important to know. So the storage, because it's going to be stored permanently on blockchain. The third thing is, based on the blueprint which you've had, obviously you're not going to build a house without following the blueprint. So those are now implementing all the methods which you put in the Starknet interface, right? And then finally, when you need like a PA who will be a PA system which will be announcing this and this and this has happened here and here and there, you should always think of events. Right. Yeah. Any questions? Any questions? Any questions? Which ID? Okay, let me start from the beginning. Which IDE are you using in this Cairo programming? So, this is just VS Code, by the way. Yes. So it's just where is my VS Code? Yeah, this is just VS Code. Don't worry about these embellishments. It's just I love being over the top. But if you, just in case you want this, normally I love coloring my various instances of VS Code because I have so many of them, and sometimes it's difficult to differentiate what is what. So to do that, we have this extension. I think because we're done, I think we can now chill and talk about these things. It's called Peacock. What is Peacock? Yes. So you can use it if you want to. So it helps me a lot figuring out what is where. So you just use it and then you go to your command palette, and then if you want to like change to something, and you can even put like other colors. You don't have to like share. You don't have to like use specifically the ones which are written here. You just write like the hex. This is the hex code, right? I hope I'm not wrong. Yeah, so this is the peacock. Also, let me see. Let me see something else. Yeah. Also, to be able to effectively set up your Cairo developer workspace in VS Code, there's some. Why is it? Why? Why are you not working? Okay, yeah. No, I'll update later. Yeah, so example, this is Cairo. This is like is it the language server? Let me not start talking what I don't know, but yeah. So we have this Cairo extension, and we have the Cairo syntax. As you can see, our syntax is highlighted really well. So this is because of this extension here. And if you also remember Cairo, the first version of the Cairo was Cairo 0, right? But we have Cairo 1.0. So we have that one. What else have I added here? So I haven't really used this yet, but we have like the Starknet Explorer. So it's not really important, but these three are. So the Cairo syntax to help you have syntax highlighting, because if you don't have it, otherwise your code will look bland. So it will also be difficult to debug, right? So, and then we have now Cairo, the LSP, if I'm not wrong. And then we have the Cairo 1.0. So after installation in your terminal and every other thing, so that you can be able to like properly and comfortably work with Cairo programs and Cairo smart contracts in VS Code, you just install this extension. Yes. Do we have any other question? I was keeping. Okay. Let me just drink water. Yeah, my voice is. Notion link. Okay, Notion link. Are you on LinkedIn? Yeah, I'm on LinkedIn. I normally actually don't. I'm very inactive on LinkedIn. Actually, I don't have much to talk about over there. I find LinkedIn to be very. I love Twitter, but now I've lost the account. So, but I can share it. Just look for Cynthia Kamau. Yes, just look for that on LinkedIn. Yeah. Okay. Yes, I also thank you so much. I hope I understood at least something. I also on my end the reason I love using stories it's because it also helps me understand a lot of these abstract complexities that you're facing with, right? So analogies are really good at getting the principles. Yes. How do we connect? As of now, it's just LinkedIn, but we still in Telegram. Once I get my Twitter account back, yeah, we can connect also on there. Okay, nice, nice. My email. Well, just text me on Telegram, please. Um, I'm very paranoid right now because I'm being hit left, right, and center. Yeah. So this is just on Telegram. I'm also on the H.E.R bootcamp group, so you can just like text Cindy and I'll see. Yeah. Thank you guys. Thank you guys. Will there be an assignment? If you guys want to, we can put an assignment. Yeah. Like example, you can modify like the smart contract which you've talked about and you add events just to like run around with it. Yeah. So we can always give an assignment. Yeah, but I think I can work on that like tomorrow morning. Yes. If you guys want to. Yes. But otherwise, thank you guys. Thank you guys.
Thank you so much, Cindy. This has been a really amazing session. I feel like every day I'm just learning something new about Cairo, and it's just really exciting. And I also just quick feedback. I really love the storytelling. It makes understanding even easier for someone like me who's just like learning about Cairo and exploring Starknet. So I really appreciate it, and I hope that you can. Everybody else also like was just greatly impacted, and they also obviously I see from the chats that most people actually loved the session, they enjoyed it. Thank you so much for the session, for the amazing session. I think we'll put up a feedback form tomorrow because tomorrow is going to be like the last session for the week. So put up a feedback form. Happy to see all the feedbacks. Happy to see all the suggestions. Feel free to share. And yes, so about the assignment also, it's really good that you'll want assignments. So you can definitely create something real quick and add you on GitHubs and see how those assignments will come through. Otherwise, thank you so much, everybody. I don't know if there's anyone else that has something to say, real quick. Last chance, and then you can just wrap up, and everybody could at least rest for the day. Yeah, so the recordings will actually be uploaded tonight on the Notion page. So if you check the Notion page, you have like the virtual workshop sessions. So for today's session, today is 5th. So we'll post the link against Cindy's session on 5th. So like see the recording, see the presentation. And then if you have any questions, we have link to the Telegram chat also on the Notion page. So feel free to ask in the chats and feel free to tag Cindy, and I'm sure she'll be of really good help. Yeah, so I think that's that from me, and we can close the session and call it a night. Thank you so much, Cindy, and thank you so much, everybody, for joining the session. Thank you for being consistent. We are going to be making a really exciting announcements for people that are actually consistent with the session, so stay tuned. And yeah, I think that's it from me. I shall call it a night, and good night, everybody. Bye.